This is the second video from your notes on how to solve with matrices by hand. This is going to start with us setting up the matrix equation. So we're going to write down a 2 by 2, a 2 by 1 equals a 2 by 1. So the first thing we're going to do is we're going to look at our solutions, see how they come after the equal sign. They're going to go line up in here. Okay, so that's going to be my 8 and negative 4. My two variables I'm working with are x and y, and they are in the correct order. So x and y, if they are not in the correct order, they need to be rewritten in the correct order. And then what I'm going to do is I'm going to shake out or ignore the variables in this part here. And those constants or coefficients of those variables are going to get written down in the order that they are. So I have negative 11, negative 6, 5, and 2. So the first thing we're going to do after this is I'm going to find my determinant. My determinant is found by looking at my diagonal of AD and my diagonal of BC. With that, we are going to do the math. So I'm going to take A times D minus B times C. You can just jump into negative 11 times 2 minus a negative 6 times 5. If I have negatives after a negative sign, I definitely like my parentheses. You can use as many parentheses as you want. Plugging that into my calculator, I get negative 22 minus a negative 30. So I get this value to equal 8. So with that, I'm now going to set up my matrix inverse. So the inverse of my matrix that has the diagonal of the blue and green x starts by saying 1 divided by my determinant, which is 8. And then I'm going to set up this matrix after I write things out. So I have this, and then my original problem of negative 11, negative 6, 5, and 2 with my x and y equals whatever I do to one side of the problem, I need to also do the other side. So I'm going to throw a 1/8 in there. On the left side, a blank matrix. And then I'm going to write down that 8 and negative 4. If this is the first video you are watching today, or you are looking back at this question just to make sure you understand it, what I'm going to do is I'm going to create the inverse of my original matrix, negative 11, negative 6, 5, and 2. And in order to do that, A and D need to switch spots. So on that blue diagonal right here, I have negative 11 and 2. What they are going to do is they're going to switch their locations. So 2 is going to go up here, and negative 11 is going to go down here. And then on that green diagonal, the numbers I have are going to change their signs. So 6 is going to become a positive 6, and 5 is going to become negative. That matrix is going to get copied over because whatever you do to one side of the equation, you need to do the other side of the equation. So I'm going to throw the 2, the 6, the negative 5, and negative 11 right there. And then I'm going to work on matrix multiplication. Now, in order to do that, I'm going to multiply these two matrices first. And I will do that here. And if you're still struggling with matrix multiplication, remember that it's a 2 by 2 times a 2 by 2. So I'm going to have a 2 by 2 as a solution. So there is my row 1, 2 columns, row 2, 2 columns. And then over here on the other side, I have a 2 by 2 times a 2 by 1. And so I'm going to write that over here as well. Don't need as much room, but I'm going to write that out. All right, and this is just a visual thing. So with this, I'm now going to do the math. So row 1 is 2. Whoops, wrong color. Let's go back to purple. 2 times something plus 6 times something. And this is coming from that red matrix. And row 1 is at 2 and 6 on the left side before the 8th. And we're just going to bring the fraction down here in just a minute. We could work with fractions, but we all despise fractions at one point or another in our life. So right now we're just going to wait off on that. Row 2 is 5 times something plus negative 11 times something. Negative 5 times something plus negative 11 times something. What values are going to go there are from my wonderful columns. So this is column 1. This is going to be column 1. This is column 2. This is going to be column 2. So with those numbers, 2 times negative 11 and 5. It's going to go on top and bottom. And then column 2 is going to be 2 times negative 6 with a 2 and a negative 6 and a 2. With that, I'm going to simplify using my calculator. I'm going to bring that 1/8 down right here. And I'm going to simplify, not as that color. We're going to bring a blue in. All right. And with that matrix simplified, negative 22, 2 times negative 11 plus 30 is going to be a positive 8. 2 times negative 6 is negative 12, plus 6 times 2 is a positive 12, so that's going to be 0. Negative 5 times negative 11 is 55, and negative 11 times 5 is negative 55, so that gives me a 0. And then negative 5 times negative 6 is positive 30, plus a negative 22 is going to give me an 8 again. Our goal is to check to make sure that the inverse matrix that we found matches what is in front of our fraction, or sorry, what is in front of that matrix, which is your 1 divided by your determinant. And if those numbers all match, when you multiply 1/8 times 8 or take 8 divided by the 8, you get 1, and that gives you the identity. But over here off to the side, we're going to do the same work again. I'm going to bring that 1/8 down. And I'm going to write down here in a dark blue what this is going to work out to be. And then I'm going to go over here and I'm going to do the same matrix multiplication based on my rows. Remember, row 1 times column 1 is going to go right here. Row 2 times column 1 is going to go right here. So with that, 2 times something plus 6 times something, so row 1. Column 1 is going to be an 8 and a negative 4. And then row 2 is negative 5 times something plus negative 11 times something. And that column 1, once again, is going to be an 8 and a negative 4. With those, I'm going to plug those in my calculator, and I'm going to get 16 plus a negative 24 is going to give me a negative 8. And then negative 5 times 8 is negative 40, plus 44 is going to give me a 4. So now that I'm here, I'm going to take 1/8 times each part, and I'm going to check that I get the identity matrix. This is 1, 0, 0, 1. That means the two matrices I had that I created, the inverse and the matrix I had with the scalar on the outside, are truly inverses of each other. You do have to either put the matrix of the scalar inside the matrix or you have to keep it on the outside. Your choice there. But you cannot divide them out because that's not how math works. And equals my final solution over here on the other side. It's going to be a light blue when I write it down. Negative 1 and 0.5 in my calculator. If you wrote it as a fraction, makes my heart all happy and everything else. But since this is a point, we'll write it as 1 and then 0.5. All right. That is your final solution. And we will talk more about all the work that we did on the left side of the matrices. You do not have to do it on this question, but it does make it a lot easier if you do. If you choose not to do that, then we will do that on the problem that will come after this on the test.